Okay, so let's get into this unit circle now. So first thing I want you to observe is that our vertical line is the y-axis. Our horizontal line is the x-axis. Okay, so we're putting the circle onto the Cartesian plane. First thing I want you to realize. Secondly, we call it the unit circle for a reason. It's because the radius is 1 unit. Okay, now if the radius is 1 unit, and this here lies our origin, then from the origin to the perimeter, we have this coordinate 1, 0. And likewise, over here, we have the coordinate -1, 0. Now, our y-intercept up here is going to be 0, 1, and down here, we have 0, -1. Okay. Now, in our last video, we talked about the 2 different triangles. So let's put our first triangle in. Here is a 45-degree angle. Okay. And what is our radius? Our radius here is 1. Just like our last video, the hypotenuse is 1. Now, can you remember the values for this side and for this horizontal side? They were √2 on 2, and the vertical side was √2 on 2 also, because they had to match. Well, that means then that I know what this coordinate up here is. This coordinate is along the x-axis, we have √2 on 2, and then along the y-axis, we have a distance of √2 on 2. And there's our first coordinate. Okay. Now, I could use my symmetries, and I could say, right, since this half of the circle is symmetrical to this half of the circle, that coordinate will reflect to this coordinate over here, and so this coordinate must be √2 on 2 and √2 on 2 also. However, remember that to the left of the origin, all these x values are negative. To the right, they're all positive. Okay, next part. Let's take that coordinate and reflect it down this way. And it will reflect to this coordinate right here. And this time, it's not only to the left of the origin, it's also down from the origin. So both of these values are going to be negative. It's negative for x and it's negative for y because we're in the third quadrant. Lastly, let's reflect this coordinate over this way. And we can say that this coordinate is positive √2 on 2, because we're going to the right. And then we're going down, which means this is negative √2 on 2. And there you have it. So that's the first triangle complete. Let's now go to our second triangle. Right, just rub this out because it's going to be in my way. Okay, can you remember what the second triangle was? It was the 30-degree, 60 degrees, that's 60, and then here's our 90. Okay, so remember that the hypotenuse had to be 1 unit. That reflects our radius again for this unit circle. Then the short side was a, and the medium side was √3 over 2. So that means we can now work out what this coordinate is. Can you tell me what it is? We're going horizontally √3 on 2, and then we're going upward 1/2. Okay, and then same thing again. We're going to use our reflections from here to this coordinate, down to this coordinate, down to this coordinate over here. Okay, so we're just using our reflections. Here we go. This one reflects to this side. The x value has now gone negative, so it's negative √3 over 2. It's still positive for y, so it's a positive 1/2. Reflect it down to here, and we're going to find that both values are going to be negative, like so. Then we're going to reflect it over this way, and we're going to find that the x is positive, but the y value is negative. Okay, just like that. Wonderful. I have one more marking over here, and this is a triangle that we are familiar with. And this triangle is 60 degrees, 30 degrees, 90. Okay, So it is the 30, 60, 90, it's just been rotated slightly differently, okay? But the ratios are still the same. So the hypotenuse is still 1, the short side is still 1/2, and the medium side is √3/2. So let's put this coordinate in. The coordinate is going to be, along the x we have 1/2, and along the y-axis we have √3/2, just like that. Now you'll notice the similarity between the 60-degree triangle and the 30-degree triangle is the same values, aren't they? They're the same values, but they've been swapped around, which makes perfect sense when you think about it. So once again, let's reflect this over, and the 1/2 becomes a -1/2. It's still √3/2 along the y-axis. Let's reflect that coordinate down to here now, and we get -1/2, -√3/2. One more reflection brings this coordinate over here, and we have 1/2, -3 on 2, just like that. So all the coordinates are now finished. We're now ready to put in our angles. Okay, let's do that.